Should have just got back from shooting stars. This is the pre-work that you would have done with the heading of the ship right here. So you would be out there shooting the stars and you're heading, looking at these guys, specifically trying to hit these three with the stars by them, or any of them. Now the shot that I took, I just took off of a test. So there are only 3 stars. I know they work because it's part of a test. And the times are a little bit weird. 18:45:00, 19:10:00, 19:30:00. This is zone time, the time on my watch. It's not going to look like that when you do actual shots. There's going to be funny seconds and things like that over here, and you're just going to have to deal with that. I'll show you how to do that, of course, when we work it down a little bit more. And these 3 stars don't match up with what's going on up here either, but they would match up for the shot that you did. But just for demonstration's sake, I'm going to start with this right here, with these 3 stars, and we're going to work them down from the beginning. So I've got this document right here that is pretty much the reduction strip. So there's a lot of little steps on here, and that's what we're going to go through on this one piece of paper right here. I may use a little bit more to go through every little step, but for the most part this is it. So when I do this, I like to write the little key thing over here on the side: zone time, zone description, GMT, HS. That's enough for right now. The 3 stars that I shot are, well, that we're going to be working with right here are Rigel, Peacock, and Marcab. Okay, and if you want to make it real neat and tidy, you can just put a line down the page right here, another line down the page right here. You can jam as many stars on one piece of paper as you want, but paper's cheap and you should use it. Use a lot of paper so you can have space to write. So the zone time of Rigel, which is the time on my watch that this shot was made, was at 18:45 minutes, 00 seconds. HS is the height of the sextant that I read, and that gets 20:02.6. So there's one shot. The bearing in this thing doesn't matter. Okay, we're going to do the bearing later on. Peacock, that one was shot at 19:10:00. The HS on that one is 32 degrees, 50.6 minutes. And Marcab finally was shot at 19:30:00. The HS there was 40:59.5. So those, I got, this is, it's going to look just like this when you come back from shooting the stars. Those are the important bits of information: the zone time to the seconds, and the HS to the tenths of a minute. That's all information you're going to need. Let's see, this shot was also on December the 12th, I think. Yeah. And of course we're going to pretend it's 1981 for the Nautical Almanac purposes. Now the DR that I had for this one was on a different piece of paper somewhere. Here we go. So my DR position at star time was 24:25.2 south, 31:31.1 west. I'm just going to put that right up there at the top, 1981. And the zone description that we're working with right here, remember you divide 41.5 degrees by 15, blah blah blah, that gets you ZD minus 3 in the Western Hemisphere. So zone description of 3, if it is 1800 in the Western Hemisphere, it's going to be later at Greenwich, so I'm going to add 18, 19, 20, 21. So GMT time here is 21:45:00. That's the exact time at Greenwich that I made this shot of Rigel. Same thing over here, add 3, add 3. It's nice to work them all down together because you do the same thing over and over again, and you want to cut out the chances you're going to make a mistake. 19, 20, 21, 22. 22, 10, 00. Same, 22, 30, 00. GMT times right there. Okay, so now I got the first 4 bits filled out. HS. Now we have the index correction. Now comes the Nautical Almanac. So we need to start making corrections of this with the one we want to get to here is called HO, which is the height observed of the body of this star. So right in the beginning of the Nautical Almanac, they set it up really nicely for you, so you can start going in here. So the I need index error first. What did I see? Index error. So I put in a practice index error of, let's say this is when it's on, it's off, and when it's off, it's on. So I'm looking at my sextant and I'm turning it, and to make the horizon line up perfectly, my little vernier scale actually reads 1.3 minutes on. So what I want to do, I'm sorry, 1.3 minutes off, so it's a little bit below 0. So what I'm going to do is I'm going to add an extra little bit onto here of index error for my sextant. And most all sextants have a little bit of index error, even the ones that tell you there is no index error. There's probably a little bit. 1.2, I'm going to add it here, and I use the same sextant throughout all of these. So right here, I've got this guy right here. So this is going to be a corrected HS 2003.8. Adding this right here, 3251.8. And great, this one we're going to use the calculator because it's carrying over. So 59.5 plus 1.2 is 60.7. And I'm just going to leave it like that for right now, which I think should be okay, because I think we're going to do some subtraction here in a little while. So, I corrected HS. And then the next thing we need to do is something called the altitude correction tables, which is right here. And this is for, so there's something right in there, there's an index error. I need to fix my strip a little bit. Oops, right here. Index correction, IC. You get that from right here. And this is for all shots that are in between 10 to 90 in apparent altitude. So for the stars, we're going to go, my mistake, I don't need to add that in there. IC is index correction or index error. That's right. The next thing we do is dip. So dip is like if I'm a little dude and I'm standing on a building like this, I can see farther over the globe as this little guy gets up taller. Or if I'm standing in a rowboat, my height of eye is 0. If I'm standing on a ship, it's going to be something like 50. So you did all your shots, or I said that I did all my shots from something like 44 feet. So my dip correction, 44 feet is the deck that I'm standing on down to the surface water. So here's dip inside the Nautical Almanac, and here's feet. So I'm going to go down here, 42.8, 44.2. So I'm right in between there. So then I go, this is height of eye in feet, this is meters, forget the meters. Right here, minus 6.4. I'm going to write dip, minus 6.4. And that's across the board because I shot all my sights from the same place. Right here, first of all, we got another little trick right here. You can't take 6.4 away from 3.8, but I can do a little bit of a borrow. So I'm going to change 20 to 19 and make this 63.8. And once you do this again and again, you can start to get that in your head. 63.8 minus 6.4, 57.4, 19 degrees. Okay? And that is going to be HA, which is height apparent. Right over here, 51.8 minus 6.4, 45.4. Just carry this right on down. 32. HA right here. And it's a good thing I didn't fix that number because I'm subtracting now. Bada bing. HA for all three of my stars.